Right, sorted out my grounding on the output stage a little bit better. I'd like to have done it a lot neater, but anyway. So we did have this big 130 ohm cathode resistor for both the valves. Yeah, I think it's better individual cathode bias resistors for each valve. So what I've done is just tacked in a couple of 270 ohm resistors. I just pulled that straight off the EL84 datasheet, and I've just tacked in a couple of 47 microfarad capacitors bypass caps. Same on this side. Tacked them all into the same place. This is the grid leak resistor. Tack that into the same spot. Same there. And this is our grid leak resistor going to the control grid. I've left this pretty much as is here. Again, I would like to make it neater, haven't got the time. And then that is going straight to our negative terminal of our main reservoir capacitor. So that's all good. So next, this is a sort of ground here. That was going to this point here. That goes there. This is a grid leak resistor, I presume, for this EL83 stage here. God knows what's going on there. Yeah, I'm going to have to get my head around that at some point. Right, getting towards the end of the day now. Lights fading fast. Sun, what there was of it has gone in. So we're a little bit further forward. We've got the output stage pretty much sorted out. Still got some superfluous wiring in there. So there's the output stage cleaned up. Ground sorted out. We've got C5 and 4 in, which is this cap. 47k, yeah, 47k dropping resistor. I replaced it. We did have a 10k, whoops, we had this 10k in there which measures about 13k, which couples this capacitor to this one, so that's got to be sorted. So I had to basically bolt that in. That's the easiest way I could think of doing it without taking this one out, drilling a great big bloody great big hole, putting another clamp in. It was just leave it in. Like I said, I'm trying to get this done quick, etc. So where are we? Yep, blah blah blah. So then we come over to the phase splitter. I've tidied this up, although I mean it's still a bit of a rat's nest. What I've done, I've basically dressed component lead lengths, like resistor lead lengths, to try and keep them short as possible. We've got a less than perfect heater there, and I've tried to basically keep all the components, you know, especially high gain stages, away from the heaters. So yes, it's a dog's breakfast. What are you gonna do without starting all again and, you know, doing a proper layout with tag board? Can't do that. I haven't got the time or the money. So here we had like a bar here, didn't we? We had like a bar sort of thing, bus bar. Again, shortened lead lengths, tidied it up. So this is our bass and treble. We have this wire going over to this valve here, which is our input valve, and then we've got two volume pots. So what I've done here, I've just taken it all out, mainly to try and address this heater wiring. So it should really come in over the top like this, not round. That should be more like that than that. We'll see if we can get away with that. I might be making a rod for me about later, but now everything's dressed a bit neater, we can get in. As you see, all these different chassis points that were grounds all linked up and all over the shop, got rid of them. There's only one remaining here on this base pot, but I won't forget about him. It's all logged in the old noggin. Right, and so we've now got to try and sort this out. Here it says on the plans, dress leads to reduce crosstalk. We had crosstalk, so we need to sort that out. One thing I did find, which could have been causing a potential issue. I mean, the amplifier worked, but God knows how. Where is it? Somewhere in all that lot there. This is our tail resistor for our long-tailed pair. This, he'd put a 470k in instead of a 47k. So, I mean, a lot of the chaps who watch this channel and everything are pretty experienced, but for those that don't, go back and check your work. Check it again. Get in there with a magnifying glass. Make sure you haven't done anything stupid. So yeah, I think that's all there is to say now. So I'm just going to try and get this heater wiring sorted out now. Reduce some of the lengths of the wire and get it to come in on the top. And then somehow try to get all the grounding and everything. Regarding ground, we've got our what do you call it, input jacks here. Use a bus bar there, so my bus bar is going to connect here, and then it's going to come through sort of here, hanging a bit, and then join there. You see, the easiest thing would be with this long-tailed tear, you can tell I'm tired, I need some sleep or coffee or food or something. Long-tailed pair. Easiest thing would be to do would just to ground it there, but that's not really what we want to do. Really, if we were thinking about it, we'd swap this valve here over here. That was over there, that should come here. That'd be better, and the long tail pair there, that would also work better with the ground. So we've got this stage here, which is our lowest current circuitry. That should go right at the end of our bus bar. So the bus bar should come here to the long tail pair, here to the tank control. In fact, now I've said that, that would make things a lot better, because then look, we've got a coupling cap here to this stage. That would make that shorter. And you've got this one which is a bit longer. That's not a problem, I could probably swap them round. Right, that's the plan. Sort this heat wiring out, move the long tail pair over to here. Yes, I know it's more work, should have thought about that before. Turn control circuits here, more later. Right, well, the amplifier's finished, more or less. I'm just giving it a soak test. What to say? I can't remember where I was when I took the last video. I'll just go through what I did. Right, so what did we do? We fitted a mains fuse holder, so that we've now got the live side of the mains fused. It's a single pole, single throw switch. That goes straight into a transformer. Neutral goes straight into the neutral goes straight into the mains transformer. We did a proper earth connection to chassis, which is separate from the ground. Now then, here, their earth and their ground is all at one point. I don't know if that's necessary, really. It isn't causing any problems that I can see. Blah blah. Right, so from the mains transformer out there into our EZ81, we've moved the valve holder from the, so where were we before the memory card got full up? Right, so out of the transformer into the EZ81, out of there, as I said, moved the valve holder to there because we had to fit this extra capacitor in there somewhere. The original three cap can is still there. I left that in place just to try and preserve the look of the thing. To try and fit this cap in its place would have been difficult, would have meant a lot more, you know, drilling out the hole, etc. Didn't want to do that. Anyway, so EZ81 fuse, moved that. We've got this can cap here, which is 2 times 50 microfarad. The original was 2 times 32 microfarad. Looking at the EZ81 datasheet, 50 microfarad is acceptable. I've changed the, originally there was a 100 ohm resistor across here, which is basically forming a pi filter, an RC filter. I've changed that. I think this is 510 ohms at the moment because the HT was high, and it's still high at about 320 volts. It should improve noise. Obviously it will knock the ripple down somewhat, but you know, yeah. So we've had to make it a bigger wattage, because if you've got a bigger resistor, you've got a bigger voltage drop, you know, a higher value resistor, higher voltage drop. Higher voltage drop means more heat we've got to get rid of. So let's take that off. I went to touch this the other day, well I did touch it, to see how hot it was getting, and got a bloody shock, so I'm sure it's not supposed to fucking well leak. Anywho, into there. Out of there, we had to replace the 10k resistor because that one was reading 13k. This goes into this capacitor here, so this is basically our decoupling. So we're looking at this one, and this one. C3 here is our 33 microfarad cap. I've secured that as best I can on the ground bus bar, and I put a little tag strip in there. I've used Rogers original resistors as much as I can. Anywho, so that's our decoupling sorted out. What I've tried to do, I've tried to sort the grounding scheme out. As Roger had it, it was grounded here, 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 and here. So what's that? How many heres is that? That's a lot of heres. That's, let's say, I don't know, 8 or 9 different places that it was grounded to the chassis. That causes potential hum loops, not good. And there was bloody ground wires all over the place. So what I've tried to do is sort the grounding scheme out. So what we've got our main ground down there, which is the negative, neutral, no, negative isn't it, of this capacitor. And that is grounded to the chassis in one place here. And then the bus bar goes from there to the output section. The output section comes first because it's the highest, it's the one with the highest current. I think each valve is about what, 30 milliamps or something, I can't remember. So that's basically our lion's share of our current use of the HT. But I think it's sitting at about 11 volts where it was. There's a little bit of disparity between the valves, they're not matched. but you wouldn't expect them to be. And then from there we go into our phase splitter, or ECC 83 phase splitter, which is this here. Now how it was built originally, the phase splitter was there on this valve, on this valve base. I changed it to there because our phase splitter is our next highest in current draw, and also this being our main tone sort of circuit, input tone circuit, it's nearer to the two tone pots, which made sense. What I've been trying to do all along here is to keep the lead length as short as possible. Yeah, I've cut out a hell of a lot of wire. So what is there to say about the phase splitter? Not a lot. Right, so that's pretty much all there is to say about the phase splitter. It's just a pretty simple 47k tail on a long tail pair, two 1 meg resistors going to the grounds. One grid is grounded to the chassis, which is this capacitor here, and we've got a 1k that is our actual cathode resistor. Just having a sip of beer. Meaning that our valve is biased at about -1 volt, which is what we want. We've got a little bit longer lead length there than I would like with these decoupling or coupling caps that go to the output stage, but never mind. And then coming from there we've got our input stage tone control, which is all this McGubbins here